Morning, everybody. This is going to be a slightly different video from my normal. This is more of a research update. So I've done a lot of work recently with, just showing different things that you can do with GPT-3. But what I'm going to do now is I'm going to get back to my core purpose, which is to work on artificial general intelligence, or what I call artificial cognition. I don't like the term AGI. I made another video about that. Artificial cognition is much more on the nose of what I'm doing. So years ago, I think it was 2017 or 2018, I cooked up this idea that I called MARAGI, which is microservices architecture for robotics and artificial general intelligence. Now, I kind of gave up on that idea because there was too much complexity at the time. And also only GPT-2 was available at the time, which was not sophisticated enough. Then when GPT-3 came out, I basically created a simplified version of that called Natural Language Cognitive Architecture. I wrote a book about that, and you can actually get it online for free, Natural Language Cognitive Architecture. It's right here. It's up on GitHub. And so here's the diagram for Natural Language Cognitive Architecture, where there's a shared database that links up two loops. So that's great. But now that one GPT-3 has the fine-tuned models, well, fine-tuning is out. When I created Natural Language Cognitive Architecture, fine-tuning wasn't even available. So a few things have happened. One is fine-tuning is now available. The Instruct series is available, which makes it much lighter and faster. And then the third thing that happened is I have learned a lot. I've read a lot of neuroscience and done a lot of experiments in the meantime. So I'm revisiting microservices architectures for artificial cognition. And what I'm introducing today is kind of the overall architecture. And I'm writing a book about this. It's called Symphony of Thought. It's currently with its first beta reader, actually. And then I'm working on draft 3 and so on. So look for that book in the coming months. You all know me. I work very fast. So anyways, the Nexus is exactly what it says. It's at the heart of artificial cognition. Now, what does it do? It holds the stream of consciousness. It holds all the memories that happen in artificial cognition. And basically what it is it's a vector database. So this was another problem that I had to solve. Was I could use a conventional backend like Solr or SQLite or something, but those are just not optimal for associative memory search that you need for artificial cognition. Now, enter vector databases. So this is what I started with, is VDB Lite. So this is becoming more popular. It's already got 5 stars on GitHub and 3 forks. I also created a discussion page because lots of people wanted to ask questions about it. So there you go. What VDB Lite does is it's basically SQLite, but for vectors, and it's not nearly as sophisticated. So it's a very aspirational association there. But one thing that I'm going to do is that I'm already working on this, is integrating it with FICE. So Facebook AI search, semantic search, FICE, which is very fast, very scalable. So with all that said, let's see, where are we? So there's VDB Lite. So what I'm doing is I'm going back to the microservices architecture idea, and I created a version of VDB Lite that is a microservice. It's a REST-based microservice that's called the Nexus. So what the Nexus does is it allows for an arbitrary number of other microservices to participate. So basically, we compose artificial cognition, we compose a brain, and they all talk to the Nexus. And so the Nexus has a very simple job. It receives messages from arbitrary numbers of microservices, and then it allows those microservices to then fetch messages to search for them. Right now, there are 2 primary ways to search. One is through associative memory or semantic similarity. So vector, you just do a cosine dot product of 2 vectors, and it says, here are the most similar vectors, because that is the primary way that human memory works. So human memory works by association. And so if you see something that reminds you of something else, your brain is like, ah, I've seen this before. Or if you hear something familiar, smell something familiar, you see a familiar face, you walk into a familiar room. Associative memory is the primary way that human memory works. Now, the other way that human memory works is that it is temporal. So we don't have a clock in our head, but we generally remember about how long ago something happened. We also remember clusters of memory based on memories that happened coincidentally or at the same time. So those are the two primary mechanisms of human memory, and that is what I have replicated in not natural language cognitive architecture, in the Nexus or VDB Lite. And so if you look at the endpoints in the Nexus, zoom in a little bit, there is add. So that's just you add a record. It just takes in a vector, and then it takes in, a dictionary, and the dictionary needs to have at the very least a vector and a timestamp. If that's all you use it for, that's fine, but those are the two required fields. So let's see, required time and vector. You can have whatever else you want, right? It doesn't care. And then there's search, so this is semantic search, and there's three fields required for that: vector, field, and count. So that basically says what's the vector that you want to search for similarity, which field is going to be contain the vector. I might remove this because everything just has a vector, so we might just default to vector. And then the number of results that you want. Because say, for instance, you have you just want you're searching for a Wikipedia article or something in memory. You don't need 1,000 results. But if you're trying to do something more complicated, such as curate a fine-tuned data set so that you can improve your models automatically, that's one thing that I'm testing and experimenting with and writing about, you might need 1,000 results. You might need 10,000 results. So there's search, and then there's bound, which is give me everything between timestamp A and timestamp B. And so this is how you can say okay, I found a memory that I want to explore. It happened at time index 123.456. Give me everything from time index 120 to 130, right? And so then you can reconstruct an entire memory based on what was happening at that time, what was coincidental. So those, and then there's a save function, because I realized that saving the data after every instance was getting slower and slower. So you only call the save periodically. And Solar is the same way. Solar, you send it everything and then you tell it to save once you're done. And I think you can configure it to save automatically periodically or after a certain number of indexes. So anyways, this is the microservice. And then there's a test.py, which is just, it does a quick, it sends it a bunch of vectors, and then it performs a search, and it shows you timestamps. It's pretty fast. It certainly could be faster. Ultimately, I'm going to use probably something like FAISS, FAISS, this thing, as part of the backend, so it'll be even faster. Yeah, that's the primary thing. There's a lot to experiment with, but that's pretty much it. I guess I can talk about these other microservices. So here you see I've got 6 microservices. One is the Nexus, which I just showed you. That's the first and also kind of the easiest one. And I've got the core objective functions, or what I call the heuristic imperatives now. So this is a microservice that I've actually worked on. Core objective functions. I've got all the experiments leading up to it here, which I've got 4 different experiments, plus a few others that I've started. Oh, wow, 11 stars. Some people are liking this, so that's good. So basically what the core objective functions do is it is always commenting on 3 primary principles, which is reduce suffering, increase prosperity, and increase understanding. So what this microservice is doing is it's always injecting. First it's reading the Nexus. It says what's going on. And then it's always offering thoughts about here's how we can reduce suffering, here's how we can increase prosperity, here's how we can increase understanding. And so then what it does is it does a few things. One, it reacts to the current moment. It says, this is what's going on. These are some ideas about how we can do this. Then if you have another service that says an action planning service that says, what if we do X, Y, and Z? The core objective functions will also read that and say, hey, that sounds like a good idea, that will reduce suffering, or maybe that's not the best idea, try something else. And so this is like the conscience or the conscientiousness of the artificial cognition, constantly saying, do this, don't do this, this is in alignment with what we want to do, yes or no. And this is how your brain works, right? You have parts of your prefrontal cortex that are constantly evaluating your behavior and decisions to make sure that it is socially acceptable, that it is legal, that it's not going to hurt yourself. And so the core objective functions basically form the highest order of this is what we should do. So the core objective functions can also do a few other things. They can brainstorm, right? It says, okay, given the situation, here's, 10 ideas of things to do. And so it's always just kind of barfing that information into the Nexus, which is then can be read by every other service. You can have input services, such as things that handle vision and audio, and they all dump their information into the Nexus. And this is all in natural language, by the way. So all thought happens in natural language. You're not going to be dumping in images or raw audio. That's what the microservices are for, to handle those peripherals. So this is pure thought. This is not going to be in anything other than human readable natural language, which is also important for interpretability and transparency, because we want to be able to see what our artificial cognition is thinking. I call them ACEs, artificial cognitive entity. And so then you'll have output microservices. So these are microservices that will be reading the Nexus. And as you have action planning and forecasting things that say, okay, we should do this, yes. And so you know how like in your head you make a decision, I'm going to do this. And then what? Another part of your brain, another microservice effectively in your brain, takes that decision and then acts on it in the outside world. And there's a stack of things that happen in your brain before you plan something. So you get ideas, you plan something, and then once you've got the plan, then once it's time to actually execute, that's what the output microservices are going to do. Another service that you see listed here is the agent service, or the what I'll call the agent model service. So this is the purpose of this microservice is to keep track of who am I? What am I? What can I do? Because one thing that's critical is, and this is implicit, right? You as a human being, you know that you have two hands, you have feet, you can speak, you know what you are, you know what you're capable of. So the agent model service is responsible for telling the Nexus, okay, this is what I am, this is what I'm capable of, because in order to act, you need to have some sense of self. And so one thing that most of these services do, some of these are more static, like the vision service, that's just, it's going to have, access to cameras, and it'll have, like YOLO models and other models that will dump in like a narrative of like, this is what I'm seeing, right? I see a clown running across the street, something like that. That's going to be relatively fixed. However, these other services will be learning services. So in natural language cognitive architecture, there's only two loops, right? There's the outer loop and the inner loop. With artificial cognition, with the microservices architecture, there are many, many loops. Each one of these microservices has several loops. And then, of course, the Nexus microservice, it's a REST-based service, so it's not really operating as a loop, it's operating transactionally. But so, for instance, the core objective functions, the first thing that this service will do, and the first thing that most services do, it'll look for recent messages from the conductor. And I'll tell you what the conductor does in a second. But I've done all the experiments that I needed to figure out how to build this. So now I just need to pull it all together into a microservice. So I know that what you're about to hear me say sounds very fantastical. I've done all my homework. Now I'm building it, and that's why I'm making this video. So the core objective functions, the first thing it'll do is it'll look for messages from the conductor. What does a conductor do in real life? So a conductor of a symphony orchestra tells all the different other services, or not services, sections, play louder, play faster, play softer, take a break. That's what a conductor does, is it listens to the whole orchestra, the whole piece of music, and makes sure that all the different pieces are playing together nicely. And that is exactly what the conductor does for artificial cognition, is the conductor listens to everything going on in the Nexus and provides feedback to all these services and those services modify their behavior based on what the conductor says. So the conductor is like, the prefrontal cortex of of the artificial cognition. It's the organizer of thought. It's the Borg queen. It brings order to chaos. And so the first thing that, for instance, the core objective function service does is it looks for messages from the conductor. The conductor can provide feedback such as slow down, speed up, or focus on something, right? Because directing attention, you don't want services to go like focus on the wrong thing, because especially when you have many services all reacting to each other, they need guidance as to what to focus on, and that's what a conductor does, right? This is where we are in the piece of music. Focus on this measure right here. So focus on this problem. This is where our attention lies, because the Nexus is completely agnostic. It doesn't care about what's going on. It is just a message broker. And in fact, I originally used stuff like AMQP, a message broker, to do this, but now I'm doing vector database. So the conductor focuses on handling attention, and I've done all my homework. You'll see it in the book. You'll see it in upcoming videos, in terms of prioritization and what to focus on. So the conductor will be periodically issuing messages. This is what we're working on. That's called cognitive control. So if you have like ADD or ADHD, or you're really tired and you can't focus, it's because your mental conductor is like, let's do that. No, let's do that. Let's do this instead. It means you're easily distracted. So what this conductor will do is it'll say, this is what we're focusing on. Everyone go at this pace. Let's make sure that we're working in a concerted effort. Concerted effort. So that's the first thing that a microservice does, is it looks for messages from the conductor and modifies its behavior accordingly. And then it reads the rest of the messages that have happened recently, or older messages, depending on what it does. Because, so say for instance, you have a service that's like trying to answer questions or trying to remember, the ancient past. It might search for older memories, right? So it'll start by saying, okay, what is currently going on? And so that says like, give me the most recent time window. And then the service, depending on the service, it might also use those associative memories to say, okay, this is what's going on right now. Now give me everything from ancient history that is related to what's going on right now. So this is, for instance, this is why if you walk into a room, you forget why you walked in there, because your brain gets a different set of memories. It says, I'm in a new room. Let me grab the memories from this room. And then it forgets the memories that you had in another room, which is where you were when you decided to go somewhere else and do a task. The same thing happens, like, you go to work and suddenly you remember like, oh yeah, like, because it's a different setting, it feels different, it sounds different, it smells different, you see different people, and so you have this entirely different context, and it dredges up different memories. That's one reason, for instance, as soon as I finish this video, I'm going into the office. My work productivity changes. It's not that I'm more or less productive. It's that my brain is in a different context, so I do different things when I go into the office. It's working differently. And so that's what I mean by associative memory. So you pull temporal memory, you say, what's going on right now? And then you pull associative memory that says, give me everything else that's related to this. And then whatever the microservice's purpose is, it will then do its work and then contribute some messages back to the Nexus. So like I said, for core objective functions, what this does is it can help brainstorm ideas about how to adhere to its principles. It can also provide admonishment. So for instance, if you yell at your artificial cognitive entity, it says like, hey, you really hurt my feelings. The core objective functions will be like, whoa, hold on, we caused suffering. And it'll add messages saying we need to do better next time, right? So it'll be self-monitoring. I've already done all these experiments. I know it sounds really fantastical when I say it out loud, but I have done the experiments, and now I just have to put it into the microservices. That's why I'm making this video. Okay. So then what happens? So that's first it just looks for messages from the conductor. That's why there's the dotted lines, because they don't communicate directly. All communication goes through the Nexus. That is the broker, so that you can have an arbitrary number of microservices contributing to your artificial cognitive entity's thought. So the conductor just says, hey, you're misbehaving. Change your behavior, or hey, you're doing a good job, or this is what we need to focus on. And then, they do their recall, they pull all the necessary memories from the Nexus and do their thing, contribute it back. Okay, that's great. But then what do they do offline? What do they do? How do you learn, right? Learning is not one monolithic thing in intelligence. Your whole brain learns, right? It's not like, oh, I have a filing cabinet in my head. That's not how learning happens. What happens instead is that every section of your brain, every component updates, right? You have parameters and biases and weights, or in organic terms, synaptic connections that update globally, right? And so like when you practice something, you're forming new global connections all over the place. It's not just one like pile of data. And so what happens is, as there's more data in the Nexus, what these microservices will do is that they'll pull that data out that says it'll search for data that's relevant to its function. So in the case of the core objective functions, it'll look for cases that it succeeded in reducing suffering. It'll look for cases that it failed in reducing suffering. And what it'll do is it'll automatically curate those data, into those memories into data sets, and then it will fine tune newer models in order to improve its performance in the future. Now, another thing that these microservices will do is they're not just going to have one model. They're going to have their original model. They're going to have every new model that they're trying. And what they'll do is they will measure the performance of their own model. So this is one thing that I'm writing in my book, is that every microservice is going to be responsible for its own performance. And that means that each microservice is going to have its own objective function or something that it's measuring against. And basically that objective function is just how it decides to cultivate and curate those internal data sets. And so over time, as our artificial cognitive entity gets older, the Nexus will have more and more memories, right? It's going to start off with tens of thousands of thoughts and memories, and then hundreds of thousands, and then millions, billions, trillions. So this is going to need to scale really big, which is why I need to integrate the Facebook AI semantic search as soon as possible, because this is going to be a big search problem. So then imagine you've got 1 trillion data points to curate new models from, right? That's great. Data is fuel for artificial intelligence. And so the Nexus is going to be responsible for holding all of that data. And then these microservices are going to say, hey, give me this data. Let me chew on this and learn in the background. And then as it trains new models, it'll test those models. We've already got this in ML ops, right? There's auto ML, which allows you to automatically do side-by-side comparison of models against known problems, known data sets. And so it'll need to do all that in the background. Again, because this problem space is so clearly defined for each microservice, it shouldn't be that big of a deal. I say should. I'm probably going to eat my hat on that. And so in that respect, your core objective functions are going to improve over time, but they're also always going to adhere to those 3 principles. Then your agent model will also improve over time, because as your artificial cognitive entity gains more experiences about what it can and cannot do, it'll form a more clear identity, a more solid identity as to, this is who I am, this is how I work, this is what I'm capable of, this is what I'm not capable of. There's a slew of other services that I'm planning, such as planning services, anticipation services, and so on. But this diagram is just kind of like the high level of what I'm doing. So right now, what have I got? I've got a prototype version of the Nexus. What else do I have? Not a whole lot else other than the core objective functions. I've got the experiments here. So that's going to be wrapped up into this microservice before too long. Then I got to work on the conductor. I've got all the experiments there. Anyways, I guess I'm repeating myself now, so I will go ahead and stop the video now. But this is what I'm working on. Thanks for watching. Like and subscribe, and consider supporting me on Patreon. Thanks, and have a good day.